Hi, can you hear me?
Yes, sir. Good evening, sir.
Yeah, good evening. Okay, so we have discussed so far polynomials, quadratic equations. We'll start with a new topic from today. This is number theory. Uh, we'll start with some basic questions that have appeared in number theory section in the exams in the last 10 years. So today's class will not talk about too many properties, but we will go over some of the properties in the coming classes. Uh, but today is basic number theory that anybody can attempt. Let's look at some of the problems. So the first one is this one. Using the fact that square root of n is irrational, whenever n is not a perfect square, we have to show that the number s, which is equal to root 3 plus root 7 plus root 21, we have to show that s is irrational. Okay, so this is the first problem. Think about it. You have seen proofs of things like square root 2 is irrational and all from very low classes. So similar concepts, but slightly more advanced problem. You have to prove that s, which is root 3 plus root 7 plus square root of 21 is irrational. The hint here is that try a proof by contradiction. Any ideas, anyone?
So I was trying it by factorizing it, like writing it S plus 1 equal to root 3 plus 1 into 1 plus root 7.
Mhm.
Next, I was trying to think.
You should assume that S is rational. If you assume that S is rational, from there we can think about things. For example, you can try to find out what is S square. S square is 3 plus 7 plus 21 plus 2 into root 21 plus 2 into root 63 plus 2 into root 147, right?
Yes.
If you think about this here, this is becoming 31 plus 2 into root 21 plus this 9 can come out, becomes a 6 into root 7. And 7 can come out, 49 into 3 it is. So 7 can come out. So 14 into root 3, right?
Yes.
So what we can say here, this is S square and we have assumed S is rational. So S square is also rational, right? Correct?
Yes, sir.
Okay. S square is rational. So you can subtract this integer part from it. You can say S square minus 31 is also rational. So basically what we are getting is 2 square root of 21 plus 6 square root of 7 plus 14 square root of 3 is rational. Do you understand what I'm saying so far?
Yes, sir.
Yes, sir.
Okay. Fine. From here, what you can do is you can S is rational, so 6 times S is rational also. And 6 times S you can subtract from this. We know that this number is rational and 6 times S is also rational. So when you subtract 6 times S, what will happen? You will get the subtraction of two rational numbers will be rational and you will be able to cancel the root 7, right?
Yes, sir.
I mean, basically what I want to get is some smaller thing, a claim that is smaller. I don't want these three irrational terms. I want a smaller claim that this is rational. So, okay, let me just think. We have root 7, root 3, and root 21 here. If you maybe we should subtract twice of S from not 6 times S. Let's subtract twice of S from this number. So in that case, what will we get? Root 21 part will get cancelled. Twice of root 7, so 4 times root 7 plus 12 times root 3, right, is rational. Do you understand what I'm saying?
Yes, sir.
From this rational number, I am subtracting twice of S. And here, obviously, 4 can be taken common, and you have root 7 plus 3 times root 3 is rational, and 4 is an integer. So the number inside must be rational. We are getting root 7 plus 3 times root 3. is rational.
Yes, sir.
Okay, so this is like a simple enough claim now. We have to prove that this will lead to a contradiction. Can we do something else from here? Let's just prove this directly now, why this will lead to a contradiction, right? So I will just say that root 7 plus 3 root 3 is rational. Let's call it small s. So square it, you'll get 7 plus 27 plus 6 times root over 21 is also rational. And obviously, this part is an integer. So this implies that 6 times root over 21 is rational, which implies that root over 21 is rational. And this is a contradiction because the statement of the problem said that root n is irrational if n is not a perfect square. Right?
Yes, sir.
And right now, from our initial assumption, we have concluded finally that root 21 is rational, but 21 is not a perfect square. So actually it should be irrational, which means it's a contradiction. Do you understand that there is nothing very complicated that we have done? We have assumed that the initial number that we have to prove is irrational. We have assumed it is rational. And then I am doing squaring and subtracting all the obvious rational parts. I hope you are understanding the steps that I said.
Yes, sir.
So in a step-by-step manner, from this claim, I am getting it to, okay, saying that another number is rational, another number is rational. And finally, I have come to that root 21 is rational. It has come from this initial claim, and this claim is wrong, so this is a contradiction. I hope it is clear, everyone, what I have done.
Yes, sir.
Okay. Question number 2, you have to try yourself. Prove that ln 12 by ln 18 is irrational. And here the log is obviously to the base e. Any progress here?
Sir, we can write it as 2 ln 2 plus ln 3 by ln 2 plus 2 ln 3.
Why are you changing the font? What is the benefit?
So,
You need to show the proof of irrationality, not simplify the expression.
Yes, sir.
What have you done for the proof part?
Sir, I'm thinking.
Okay. The standard proof in such questions is obviously assume this is rational. So let's call it A by B, where A and B are integers
Okay.
with no common factors. If this is the situation, you have B ln 12 is A ln 18, or 12 power B is 18 power A, or 2 power B, 2 power 2B, 3 power B is equal to 3 power 2A, 2 power A, which obviously means 2B is equal to A and B is equal to 2A.
Right.
These two things together cannot be true unless A is equal to B is equal to 0. A is equal to B is equal to 0 is not possible, because then you will not get a meaningful expression here.
Yes.
A is equal to B is equal to 0 is not going to lead to A by B being a rational number. So that means our initial assumption of it being rational is incorrect. Is everyone understanding that this is like a really straightforward proof? Assume that it is rational, see what comes from there, get a contradiction.
Yes,
I
sir.
don't know why nobody is trying this and nobody gave me this idea, okay, let's do this and we'll get it. What are you guys trying?
Sir, I was doing this in reverse process. Like I wrote it in 2 ln 2 plus 3. Then I tried to create a part of integer and then merge it with s, which I assumed to be rational. And then I was trying to prove it, the fraction as rational. Sorry, irrational.
How would you prove something is irrational? Is there a way to prove a direct irrationality of something?
Sir, it was known that ln2 and ln3 are already irrational. So I
That's
expressed,
not a that's not an assumption you can make when the question is asking you to prove this. How do you know that ln2 and ln3 are already irrational?
okay.
Like, how will you assume that without proof? Do you know
Uh,
the proof that it is irrational?
Sir, we can create it in some power of e and then we can see.
Have you done that proof before?
No,
तो फिर उसको assume करके कैसे करोगे इसको? If you assume that it is a irrational number, then automatically everything is easy.
Right.
In the exams where proofs are being asked, you cannot make assumptions without proving your assumptions.
Okay.
Is it clear here that we are not making any assumptions here?
Yes, sir.
Let alpha, beta, C be positive numbers less than 1 with C rational and alpha, beta irrational. You have some options that you have to check. The number alpha plus beta must be irrational. The infinite sum summation I goes from 0 to infinity A alpha C power I must be irrational. And C integral 0 to pi beta cos x plus C dx must be irrational. There could be multiple correct answers.
Okay, sir.
What can you say about option A?
Sir, so I think option B, so I think option B is irrational. Sir, is it correct?
What about option A?
Option A, uh, sir, like we can assume it to be S equal to alpha plus beta, then S is rational. Uh, then we can square it. I don't think so. We are getting it.
Is your answer true, false for option A?
So I'm not sure.
Find out. I don't know why it is taking so long to
Sir,
confirm.
first option is 2.
No, it's false.
So, uh,
The simple example is 2
2 plus
minus
root
root
3.
3 and 2 plus root 3.
Sir, but how can we be sure that alpha and beta are 2 minus root 3 and 2 plus root 3?
Who is asking you to be sure?
So also 2 plus root 3 is not less than 1.
Or you think we cannot make a less than 1 uh, alpha beta irrational such that they cancel out and become rational when you add them?
Okay.
What about these two?
Yes, sir.
Do you need to be sure like of what alpha beta is to prove that this is wrong?
So like it could happen that one number was root 3 by 2 and the other was root 5 by 3.
Many things can happen, but do you understand what it means to say must be irrational?
Yes.
Should alpha plus beta always must be irrational if alpha and beta are irrational?
So I was not sure that whether we should take alpha beta to vary or to be constant.
You have to check whether this option is correct or incorrect. However, how you check it is up to you. Whether you want to make it a big deal and take 10 minutes to solve it, or take a simple counter example and see that it is not coming true.
Okay.
Do you understand what I'm saying right now?
Yes, sir.
What have you understood?
So like we can take counter examples of kind. So we can take any kind of example to show that alpha plus beta must be rational.
Must be rational.
Irrational. That's what given option.
You have not understood.
Yes, sir. To be rational, like uh,
You have to prove that this option is incorrect. This
okay,
is a strong statement that if alpha and beta are irrational, the sum is always irrational.
okay.
Is the sum of two irrational numbers always necessarily irrational?
No, sir.
So how is it not a simple, obvious false statement by taking some simple example? How did you spend 5-10 minutes to think about it?
Right.
You have never seen conjugate irrationals adding up to rational number.
Yes, sir. I've seen.
So this statement was very difficult to figure out.
No, sir.
And one person is saying it wrong. The other guy, you are saying that it is true. How is it true? Madhur,
Yes, sir, I thought of a proof like S is equal to alpha plus beta. So I did not think of the conjugate case there.
do you understand what I am saying right now?
Yes, sir. Now understood.
It is not necessary that the sum of irrational numbers is irrational. There are so many examples that it is not. You just
Yes.
have to take one counter example and see that this statement is clearly false. What about statement B and statement C?
So here I think both are true.
What is the reason?
So for the B part, we are getting the sum as alpha divided by 1 minus C. So, so 1 minus C must be rational.
1 minus C must be rational. Okay.
So irrational by rational, I think should be irrational.
Okay.
So for C part, we get the value to be C pi. Since C is rational, so and pi is irrational, so it must be
Product of irrational and rational numbers will give us a irrational number.
yes, sir.
Both of them are becoming irrational because they are the product of rational numbers with irrational numbers.
Right.
I hope it is clear for everyone. This is a very easy question. The next one is this: let x be a real number such that x to the power 2014 minus x to the power 2004 and x to the power 2009 minus x to the power 2004 are both integers. Show that x is an integer.
Okay.
To show that this is an integer, you should do it in two steps. First,
So
you
we
have to
can
show
take
that x is rational, and next you have to show that x is an integer. Right now, you're not guaranteed that x is rational also. That is also not guaranteed.
Okay.
What is given is that this and this are integers. That doesn't mean x is rational.
Okay.
so we can take both to be equal to some integer k1 k2 and then divide the both expressions.
Right? You can do that. If you divide the two expressions, you should get something interesting. This is an integer, and this is an integer. First of all, you cannot divide two integers unless you're sure that the integers are not equal to 0. Randomly, I cannot divide both unless I am sure that both of them are not 0, right?
Right,
Yes.
sir?
The first thing you should say is that assume that these two integers are non-zero. If they are non-zero, for being non-zero, x cannot be 0 or 1. That's it. Right?
Right, sir.
If x is 0 or x is 1, automatically we have proved that x is an integer. Right?
Yes, sir.
So we are going to exclude the case that x is 0 or 1. And then we are guaranteed that these two integers are non-zero. If x is not equal to 0 or 1, it is guaranteed that these two are non-zero.
Yes.
And if these two are non-zero, you can divide them. And if you divide them, you should realize that you would be able to cancel this stuff. And this is a factor of this. You'll get x power 5 plus 1 is rational, right?
Yes, sir.
Which means x power 5 is rational. Correct?
Yes, sir.
That is coming by dividing the two integers, since the division of two integers gives a rational number. So you're getting x power 5 plus 1 is rational, and that means x power 5 is rational. That is the first thing. But we need to prove that x is rational. So you still need to do some steps here. So first of all, you can say that if x power 5 is rational, automatically it means x power 5 minus 1 is rational. And one of the numbers is x power 2004 into x power 5 minus 1, right?
Yes, sir.
And we are knowing that this product of these two things is an integer. And now we also know that x power 5 minus 1 is rational. This part is rational, which means x power 2004 is also rational. Do you understand why x power 2004 must be rational?
Yes, sir.
Why?
Sir, because this side we have an integer. So integer by rational should be a rational.
X power 5 minus 1 already is rational. The product of these two is integer. So this must be also rational.
Right.
So we now know x power 2004 is rational. We also know x power 5 is rational. If x power 5 is rational, you can raise it to the power 500 and you will get x power 2500. Actually, I don't need to raise it to the power 500. I need to raise it to the power 400. You will get x power 2401 actually, right? X power 2005 is rational. Do you understand what I'm saying?
Yes, sir.
Since x power 5 is rational, raising it to power 401 keeps it as rational. Now we have x power 2005 is rational and x power 2004 is rational. So obviously the ratio of these two is what? X is also rational. Do you understand how we have gotten that x is rational?
Yes, sir.
It's just a series of steps. We know these are integers. We divided them, got this x power 5 is rational. From there, we got x power 5 minus 1 is rational. From there, we got, and the fact that this is an integer, we got x power 2004 is rational. And from x power 2000, x power 5 is rational, you can also show that x power 2005 is rational. Which means now the ratio of these two rational numbers means x is rational. That proof is done. Now we have to do the proof that x is an integer. We know that x is rational. So let's assume x is equal to a by b, where a and b are co-prime integers. We are right now taking x as a rational number. Our job is to prove x is an integer. Right? I
Yes,
hope everyone is understanding what I'm saying.
yes, sir.
If x is a rational number and x is written as a by b, we will use the fact that x power 2009 minus x power 2005 is an integer. That is given in the problem. So we'll write it as a power 2009 by b power 2009 minus a power 2005 by b power 2005
Sir, actually it was
is
2004.
oh, right. So 4 is an integer, we know. So here common denominator, if I take, I'll get a b power 2009. Here a power 2009 minus here a power 2004 and b power 5, right, is an integer, correct?
Yes, sir.
So if this is an integer, that means what we can say is if prime number prime p divides the denominator, it must also divide the numerator, correct?
Yes, sir.
If it's an integer, all of the stuff must cancel out, all the prime factors, right? Is everyone agreeing with this statement that if prime p divides the denominator, it must also divide the numerator?
Yes, sir.
Right. So what we will do is we'll pick some prime number because the denominator only has b. We will pick some prime number p that divides b. So obviously if p divides b, p divides this. And now we are going to say that because p divides the denominator, p must also divide numerator, right? Correct?
Yes, sir.
So that means p divides a power 2009 minus a power 2004 b power 5. Okay. I want to show from here that p divides a. Without p dividing a, it is not possible for p to divide the whole thing, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
If p doesn't divide a, then this part will not be divisible by p. So even if this is divisible by p, it doesn't matter. The whole thing is not divisible by p, right?
Yes, sir.
So basically, we are getting for prime p dividing b, we are getting p also divides a, right?
Yes, sir.
But then p is a common prime factor to both a and b. Common prime factor. But what did we assume here? X was equal to a by b. A and b are co-prime. A and B should not have a common prime factor P.
Right.
The only common factor between them has to be 1.
Yes,
But
sir.
right now we are getting that if P is a prime number dividing B, there is P also divides A. which means they have a common prime factor, which means it's a contradiction, which means the only value of P possible is P should be 1, right?
Yes, sir.
Which means basically that X is not just X cannot be written like this, A by B, where A and B are co-prime. Which means if it was rational and cannot be written like this, that means it's an integer basically.
Right.
Is it clear what we are doing?
Yes, sir.
We are proving X is an integer by first showing that it is rational and then showing that it cannot be a regular rational number, must be an integer. So that is the conclusion of the proof. We'll be doing more problems on division, prime factorization in the next class. So revise your basic number theory. The main things that you need to look at is division, prime factorization, and proof problems based on these. So try going through your basic theory. We'll discuss more previous year's questions and continue with the number theory discussion in the next class.
Okay, sir.
Okay, that's all for now. We'll continue in the next class then.
Thank you, sir.
Thank you, sir.